Hi! This example deals with the perimeter of a rectangle, the idea of perimeter. And they begin by giving us a formula for the perimeter of a rectangle. They say it's the sum of all the lengths of all four sides. Remember here in mathematical language the word sum always means addition. So we obtain the perimeter of a rectangle by adding together the lengths of all four sides. And they've also defined some symbols for us. They tell us the symbol W will represent the width of the rectangle, L will be the length, and the P will be the perimeter. So we could write the formula for perimeter in words by saying perimeter equals length plus length plus width plus width. To visualize that, let me draw out a rectangle here and say if that's my rectangle, I have the length on this side, and the length of this side, and the width of this side, and the width of this side, and I have to add them all four together in order to determine the perimeter. When we think of perimeter, we can think about building a fence. It's the distance around the outside of that shape. If we want to write this as an equation with just symbols, we might say P equals L plus W plus W. Or sometimes you'll also seen it written as, notice there's two L's and two W's used, you might see it written as P equals 2 times L plus 2 times W. So there's some background on perimeter. Now let's take a look at these three rectangles we've been asked to draw. So let's sketch out a rectangle here. And let's pick any value we like for the length. Suppose this rectangle has length equals 2. And length equals 2 over here. Well, that means so far the distance around this rectangle is going to be 2 plus 2, which is 4. But we know the total distance around has to be 18. So to figure out what the width would need to be, we could take that 18 and subtract off the 4, which will give me 14. Which means that when I add this width and this width, I'm going to need to get to 14. And then I could take that 14 divided by 2. Tells me the width must be 7. So that would be one rectangle that would meet the criteria given. Let's think about another example. And let me show a slightly different way to approach the problem. If this way of thinking shown in blue here isn't your favorite, here's another option. We can sketch out a rectangle, and we know the distance around it has to be 18, which means the distance halfway around it, in other words, one length and one width, must be half of 18. Well, half of 18 is 9, so I can pick any two numbers here as long as they add up to 9. So I could pick 1 and 8, or I could pick, for an example, 2 and 6. Oh, sorry, 2 and 6 don't add up to 9. 2 and 7, how about that? Oh, and that's the one we saw. Another example, two numbers that add up to 9 could be 3 and 6. And you can check all these. So this one would have length 1 with 8, and you could fill it all in. Have another 8 here. You can check 8 plus 8 is 16, plus 1 gives me 18. Here I have 7, 7, 2, and 2. 7 plus 7 gives me 14, plus 2 is 16, plus 2 is 18. And here 6, 6, 3, 3. 6 plus 6 gives me 12, plus 3 is 15, plus 3 is 18. So all of these would have a perimeter of 18. So we've drawn a number of rectangles here, more than the 3 required. I've drawn 4 that have the required perimeter of 18 feet. The next phase of the problem says, well, if L is 4, what will W be? So let's think about that. Here's a rectangle with a length of 4, and we've said the perimeter has to be 18 feet, so half the perimeter, one length and one width, has to be 9. If the length is 4, the width must be 5. And we can verify that that gives us perimeter 18 by adding 5 plus 5 plus 4 plus 4 equals 18. All right, the last part of this problem comes back to those keywords of variables and constants. So remember, a symbol will be a variable if it could take many different values, if it could vary and still meet the given information. As we've seen in the examples we've drawn here, there are many values of L that are allowed to still create a perimeter of 18. We could have L equals 2 or 1 or 3 or 4. So L is a variable, and similarly W is a variable. There are many different widths. We could have 7 or 5 or 8 or 6 that will all give us the required perimeter. On the other hand, the thing that can't change, the thing that remained constant in all these examples, was the perimeter. So we would say P, the perimeter, is a constant. Sorry, this should be a P here. That was the third variable. There was no variable A in this example. But P is constant because in order to meet the given information,